So, now for this one right here, let's take a look. So, what we're trying to do here is we're trying this. Remember when we were doing limits, and what was limits leading up to?
Derivative.
The derivative, right? Where we're trying to find the derivative. So the precursor, like the building block for a derivative, was a limit. So we had to find a bunch of stuff that, you know, goes along with that. And that's what we're trying to do here. Okay, this, we're actually trying to eventually get to the point of find area. So that's going to do the integration over a certain period. So if we're looking at it as position, integration of my position will give me the area under the curve. And so the area is what we're looking for under a line. For this problem here, your calculators are going to be helpful. So I'm going to have you guys all grab these here momentarily. But
am I going to need the done set or no?
Yes, probably. No, you're not. Okay.
The real.
It took me a second. I thought you meant like the real thing.
Yeah.
Okay. Now, but
Still by this, so it's called the done set.
so sigma notation. Okay, this is sigma. Okay.
I ate some time.
Yes.
I hate some pie.
Now, the sum of n terms a1, a2, a3, all the way a to n is written as when I equals n. So we're going to plug in n for what I have to the nth term. Okay, where I is the index of summation. Okay, a1 is the ith term, so that's going to be my first term for this one, or whichever term I'm starting off with, and the sum and the upper and lower bounds of the summation are n and 1. Okay, so starting out with this, we're going to go through and explain what this represents. So, you'll see in a second. Now, for this one right here, this is basically just saying find the sum of the numbers from 1 to 6. That's all it's asking.
So isn't it 1? Isn't it the
Yeah.
6 exclamation point?
So it's no exclamation made. That's
Oh,
factorial.
never mind.
That's factorial, and that would be a multiplication of those. Okay, so this is basically going to be 1 plus 2 plus 3 plus 4 plus 6. So 1 to 6.
7 times 3 is 20. It's 21.
21.
7 times 3.
7 times 3.
Because you add the respective terms.
5, 6, 6. 6 plus 6 is 12. 12 plus 9.
Yep. So now, yes, that is, you know, the special type of math, if you guys see that. So you could add together these two and then multiply it by how many pairs you'd be. So there's 1 pair, 2 pair, 3 pair. Because each pair, the top and the bottom add up to the same thing.
Oh, yeah,
And
did it
if
by
it's
the
a non, you just
like
add
the
the
yeah.
standard value. Shout out to all the birds.
Stop.
Come on, you guys! I'm recording. I try to be professional. Like my other calculus teachers actually refer to these videos too. Seriously,
Sorry.
they're like, "Hey, Pacho, what are you doing today?" "Oh yeah, I'm checking your video." "Oh, right, crap."
They talking about Dragon
yeah.
Ball Z.
I know what is that Dragon Ball Z? Did we just like discover the function of Goku's power?
Wait, I was quiet.
As it raises exponentially. Now, okay. So again, we're pretending like we know what we're doing. So the next problem is, was it I plus 1? Okay. So my first one is going to be parentheses 0 plus 1, right? Plus
0 plus 2.
0 plus 2, and just keep going like that, right?
So it's 21
It's summation.
Zero to five.
So the next number after 0 becomes 1 plus 1,
Who said 0 plus
2 plus 1,
Who said
Oh, I said that.
3 plus.
I goofed up. My bad. I read it backwards. But above.
As long as it still has to do.
So is that enough of them?
If it goes up to 5,
Yes, it's
How do I know if I have enough?
if you have 1, 2, 3, 4, 5,
6, 7, 8.
Okay, I plug it in from 0 all the way to 5, right?
Yeah.
I plug in 0 to 5? There we go. And
There's no way.
what do we get?
21.
It's 21 plus 6.
What?
Which is 20.
21
Is it-
plus 6. Isn't it just 1, 2, 3, 4, 5, 6?
Oh, wait. 21 plus 6 minus 6, which is 21.
What?
Alright. It's 21.
21.
Alright. Do it.
Okay. So how would I do this next one then?
3 squared.
You start at 3. So you go to 4.
So
3 squared.
So
4 squared.
Okay.
49.
9. Wow, what the heck?
I cannot add squares.
9 plus 16 plus 25
Save your life.
We got 50 right there.
47.
135.
Impossible.
Finally.
But I agree.
Okay.
you agree?
9 plus 16 plus 25 plus 36 plus
9,
25.
16, 25, 36, 49. What'd you say?
135.
Plus 6 minus 6.
Y'all don't believe me?
What number you is?
Hey, where's the ID?
I don't know.
Goof. Goof.
All right. So now for the next one.
Put the wrong drum.
For the next one.
Oh boy.
1 over 1 plus
Yeah, we're
1
gonna
over
have
2.
to rush. No, because then we're gonna have to get common denominators.
Damn it.
We have to find some sort of hack.
You don't need a hack. Just write it out for me.
Bad.
Yes, sir.
You want us to rationalize it or
Okay.
No. Be,
Unrationalize?
if you would rationalize each one, you know, it'd take you a whole bunch of time. That's not the point I'm trying to get at here.
Or just unrationalize?
Because these are in your notes. It's explaining to yourself what you're going to do here. Right?
So I got it.
Okay.
I look at this and say rational.
So for this right here, it's going to be, what do we have?
1 over square root of 1, which is just 1.
1 plus
1 plus 1 over rad 2. 1 plus 1 over rad 3. Plus 1 over rad. Which 1 over 2.
Thank you. That's what I was looking for right there.
Uh-huh.
So I was worried that you.
I almost missed it.
Okay. Plus
1 over rad
1 over 5 with the numbers. Change that.
5. We can combine 1 and 1 half.
we can.
3 halves?
I will.
You will. Okay. Now, this next one.
Is that just how we leave it?
What the heck is that?
Wait.
1 over n.
What? How many terms do you go out here?
This is
You're starting with.
Infinite? Infinite? Oh, infinite. Sorry.
So you're starting with 1, right?
Wait.
And so what we're trying to do is actually make an equation out of this. Yes.
That's just the answer we leave it? Sorry, for D? That's just how we leave it? Or
1 over n. So whatever number, right? You'll see in a second.
No, it's not about D. Like,
Oh, D?
That's just how we leave
Yeah.
our answer?
For your notes, yes. I'm having you guys expand it and
Just
be able
to
to
see
add
all
these
of those?
together. Yes, this is what we're trying to do.
Okay.
And these other problems are what we're trying to get at to next. So we're actually we're working our way mentally to E and F. Okay.
Got it.
So if I was to look at E, I would plug in 1, square it, right? And then 2, right? Square it. So it would look like this.
Is it n big term?
1 over n, right? 1 squared plus 1 plus 1 over n. 2 squared plus 1, right? Plus dot dot dot. But it's an n. How far do I take that?
3 spots?
To the
And
nth term. So the nth term,
Would it be 1 over n,
so it is 1 over n quantity.
n squared, plus 1.
So I'll eventually get out to that point, right?
Never really.
Did I say infinity? No, I didn't take it to infinity, did I? No, I didn't take it to infinity. It's the sum of however many parts I'll get there. So if I want it up to like the 9th, right?
Plug in the n.
Yeah, it would what would the 9th term of this? Remember when you guys actually had to do, what's that triangle called? The something Pascal triangle, right? And that's when you're looking for a certain term, right?
Huge.
Okay, you're looking for a certain term of that. This is going the same way. So if I'm looking for the nth term of this, does that make sense? So we're trying to get to that. Okay, so now this next one. So this next one, I'm going to go with, okay, let's write out what I have there, right?
Delta.
So each one, it is the function, right? So it's going to be the function. So for this, it's going to be, I'm going to make sure I write this correctly because I messed it up earlier today. Right? So the function of whatever it is plus
No, do it.
okay, and then it goes all the way out to
Is that a 1 or
x to the n delta x. That's a delta right there. Yes. Two, 3. You're right.
Three?
Sorry.
I'll trade.
Alright, sorry. Because it's my first term, second, third, right? So as we go, I just kept plugging in for the term of that. So it's eventually going to come out to be of this, of whatever I get all the way out here for my delta x, right? So for this, we're just basically plugging in for a couple things. Now, so let's take a look at our calculator, please.
Sí, señor.
Let's find it on our calculator. So if I'm looking at my calculator, I have that.
They're all over the place. Bro, you're supposed to be like every soccer player, just dive on the ground, crying.
Oh, I think I found the one with the line.
I mean, people. You saw it? You put it on?
Yeah, like I said, it's one of them.
Not that bad.
But it's still.
You see somebody scratched off like they're better than them?
Yeah.
Like what do you mean? A line.
How would they take so much time?
He has it.
Oh, can I see it?
It wasn't just this. It's not that bad. It's just like a little white line.
That's bad. What if that's where your function was?
I mean, like how'd they do that?
Okay, so let's take a look at what we have here. You know I'm recording this, right? Remember, we're pretending like we know what we're doing right now. Okay, let's pretend to be professional. All right, so
I can't.
I'm going to, you could either find it in the book or you find it right here.
the segment? Got it.
Found it. You can press the one. You can press the button next to the button.
Yeah. Right here next to the book. So for this one right here, I got it right there. So
How come yours looks better?
mine's actually a computer. So yeah, it's not as.
Yeah, I was like, yours looks way better. Ours is just mine.
It's fine. A little bit better screen than what you guys have. So anyway, I'm gonna put in. So let's take a look at some of those previous problems that we have. Let's look at what was. Let's do C. So let's try it. J equals 3.
We can use any variable, right? We don't have to use
And how many terms did we go out on that one?
7.
Went to 7. And I write
7 starting at.
J squared.
Do we have to put K?
Your variables have to match.
Yeah, as long as they match, we can use
There's a reason why I did that. The variables have to match, so I need to actually get those to match. If I change it to an X, it better be an X.
The bottom one has to be that.
Yeah.
Naomi, baby, don't need.
Okay, so now what was the other one that we didn't want to put together?
We do E?
You said D, right?
Yeah.
Or D? Yeah.
Okay, so let's do it again. Let's say D.
Cthulhu?
And what did D have?
It wasn't.
J equals 1.
Is it J? Okay.
Yeah.
So a J 1
Number on top is 5.
and it goes to 5.
Oh,
Right, 5 of them.
And it's 1 over rad J.
1. Now watch this, watch this. Now, it's important to actually set up your fraction correctly. So I'm going to do control divide.
I do that.
We'll set that up, okay? So control divide. And so there's my rad of J. Variables have to match. There we go. So my decimal approximation of that comes out to be there. Make sense?
Yes.
Okay, so like I said, for your homework today, I actually wanted to stop early because I want you guys to practice. Now for the numerical ones, you need to write out all the steps. Please.
All of the different ones?
Yes. Okay, there's not a ridiculous amount. I was looking at the homework and there wasn't a ridiculous amount of problems, but I want you to write those out. Make sense?
Yes.
So you should be okay for basically all of them. 7 through 12, you're going to work it backwards to see what your, whatever the I would equal and how many parts you would have.
Do you want to write it as it would be set up?
Yep. All right. Don't forget, like and subscribe.